So I'm going to start this video on implicit differentiation, but before I do, I just want to go back to a problem that we did in the last video and just explain it more clearly. It's problem 80, and we have a spherical weather balloon, and at any given time we say that the volume of the balloon, and this is also involves a little implicit differentiation, so it's fine. The volume of the balloon is Vt. Write the volume in terms of t, and the radius is rt, so that's the radius in terms of t, and we want to express the change in the volume over the change in time in terms of something that will give that is in the change in the radius in terms of the change in time. So we know that the volume is equal to 4 pi r to the 3 over 3, right? So saying the change in the volume over the change in time, we cannot just differentiate this because this is not in terms of time, this is in terms of r, right? But we know that if we have some function that we're trying to differentiate and we want to differentiate it in terms of a different variable, what we can say is, okay, then this is equal to the change in volume in terms of change in the radius times the change in the radius over the change in time. And this we do know, the change in the volume over the change in radius is exactly like just differentiating this, which gives us 4 pi over 3 times 3 r squared. And then we just multiply this by this, so the change in the volume over the change in time is equal to this times the change in the radius over the change in time. And then I do one more problem from this chapter, and then we'll move on to implicit differentiation. We write the absolute value of x in terms of x times the square root of x. This is problem 88, and they ask us, okay, saying that we can do this, use the chain rule to show that the change in this function over the change in x is equal to x over the absolute value of x. Now, this is a completely reasonable notation, right? If f of x is equal to the absolute value of x, then we know what the change in f over the change in x is, but we can replace this f in exactly what it is. So this is just the change in this over the dt. So this makes sense. It's just asking for the derivative of this. So let's find d over dx of the square root of x. Well, this is equal to a half times x to the negative a half. Squared. X squared to the negative a half times 2x. This is equal to 1 over 2 square root of x squared times 2x. This is equal to x over square root of x squared. Well, but this we're saying can be written in terms of absolute value, so this is x over the absolute value of x. Okay, so now let's move on to implicit differentiation. So we want to find y prime, or in other words, we want to find the change in y over the change in x generally. If we're writing this in terms of x, we want to find this by implicit differentiation, then solve it by solving for y explicitly and then making sure that the two equations are the same. So the first problem, this is on page 169, is x times y plus 2x plus 3x squared is equal to 4. And so we want to take d over dx of this entire thing, which is xy plus 2x plus 3x squared, and then say this is equal to d over dx of 4. And this makes sense, again, because this can be written, we could just say f of x is equal to x, well, f of xy. We're actually not going to say that, but this is exactly like just differentiating. Let's write that out, actually. F of x comma y. I don't want to talk about this too much, but this is exactly like taking the derivative in terms of x of this entire thing, or d of f over dx. So we can move the derivative inside. So this is like taking d over dx of xy plus d over dx of 2x plus d over dx of 3x squared, and that's equal to d over dx of 4. Well, these we already know, right? Because again, f of x is equal to 2x. It makes sense to say df over dx, which is exactly what's going on here. We're just speaking about the function directly, and that's just like taking the derivative. So this is the same as d over dx of xy plus, and then just taking the derivative of this in terms of x, which is 2, plus the derivative of this, which is 6x, is equal, and the derivative of 4, the change of 4 in terms of x is 0, because it's a constant. Now, so the one new part of this entire thing is the d over dx of xy. So, but let's think about this as a product rule. This would be the same as d, keeping this the same. So it's going to be d over, keeping the x the same first. So we're going to have x, and then we're going to take the derivative of y, which is a dy over dx. And then plus, and now we keep y the same, and we take dx over dx. Well, this is just 1. So we get plus y, and then adding everything else, we get plus 2 plus 6x is equal to 0. Or in other words, we have that y plus 2 plus 6x is equal to x dy over dx, negative, and then we move the negative over here, and we get a negative x. So that's what we get from there. So now let's solve for y. So again, we have xy plus 2x plus 3x squared is equal to 4. So solving for y, we get 2x plus 3x squared minus 4 is equal to negative xy. So we can move the negative x over here. So now we get y is equal, and then just, this is going to be negative 2, right? If the x and the x are going to cancel, we're going to get a negative, minus 3x minus 4, plus 4 over x, right? Yes. So y, or dy over dx, is going to give us negative 3 plus, so this is going to be minus 4 over x squared, the derivative of this. So are these the same? So let's write that over here. Let's move, let us erase some of this. Right, in the other section we have dy over dx is equal to y plus 2 plus 6x, y plus 2 plus 6x over negative x over negative x. So what is y? Y is just that, or in other words, right, what we said is, which is equal to negative 2 minus 3x minus 4 over x. So let's plug that in. So this is going to be equal to negative 2 minus 3x minus 4 over x plus 2 plus 6x all over negative x. So this and this are going to cancel. And then this x, so we can write this out down here as negative 3x, right? And then minus 4x squared, right? Because that, oh no, it'll be negative 3. It's going to be positive 3, because, okay, so this and this is going to give you positive 3. And that is going to give you positive, so this is positive, so this is positive. So this and this, they're going to give you negative 4x squared, and then this and this, we're going to get a plus 6. In other words, we're going to get, okay, so this is a plus, sorry, this should be plus again. So this should be minus 6, so we're going to get negative 3 minus 4 over x squared, which is what we're looking for. Good. So for the next problem, problem 2, we have 4x squared plus 9y squared is equal to 36. So solving this with implicit differentiation, we get d over dx of 4x squared plus 9y squared is equal to d over dx 36, or in other words, 8x plus, and when we take d over dx of 9y squared, again, we can't really talk about this because that y is not in terms of x, so how do we take this derivative? Well, but we learned that if we want to take, let's say we have y is equal to u squared and u is equal to 3x, and we want to take dy over dx. Well, y is not in terms of x, but u is, so this is the same as taking dy over du and then du over dx. So similarly for us, what we're going to do is we're going to take, this is going to equal to d of dy and then times this thing, so it's going to be d over dy of 9y squared, and then times dy over dx, which is basically this part, ignoring the notation. The notation might be a little tricky, but that's what we get. Or in other words, what we're going to get is 18y and then dy over dx. So what we get over here is 18y then dy over dx. That's equal to 0. So what we have is 18y dy over dx is equal to negative 8x. Then we're just going to divide by 18y. So that's what dy over dx is. So now, let's just write that down here. Dy over dx is equal to negative 8 over 18y. 8x over 18y. So now let's array solve this. And solve for y. So we have 9y squared is equal to negative 4x squared plus 36. So then we divide by 9. So then we have y, sorry about that, y is equal to plus minus the square root of all that. So so then we have dy over dx is equal to plus minus 1/2 negative 4x squared plus 36 over 9 negative 1/2 times negative 8x plus 36 over 9. And I am not going to actually check if these are the same. Plugging in y, you have to plug in y, but I assume they are. Someone can plug it into a calculator and see. So problem 33 is 1 over x plus 1 over y is equal to 1. So by implicit differentiation, again, we have d over dx of 1 over x plus d over dx of 1 over y is equal to, well, let's just write 0. So this is going to give me negative 1 over x squared, right? That's just the derivative of this thing, which we can talk about. This thing, again, is a little tricky because we're trying to take d of this thing in terms of x, but this is not written in terms of x. So what do? Well, again, we can say that this is going to be d over dy of 1 over y, and then times d y over dx by the chain rule. So in this, we know this is just going to be negative 1 over y squared. So this is going to be minus 1 over y squared times dy over dx. That's equal to 0. So what we get is negative 1 over x squared is equal to 1 over y squared dy over dx. And so you just put a y squared over here. So that's what you get. So now let's try it the other way. Hopefully this time we'll be able to verify that they're the same, because they won't give us a complicated expression, right? So dy over dx, we said is equal to negative y squared over x squared. So now what we can say is 1 over x is equal to negative 1 over y. We move the negative over here. We flip it, so we get that y is equal to negative x, right? We can take both of these and just divide them by 1, and that's what happens. We just flip them. Or if you know cross multiply, just do that. So if y is equal to negative x, we can plug that in here, and we get dy over dx is going to be equal to negative, and then you're going to have negative x squared, which is just going to give you x squared over x squared, so this becomes negative 1. And over here, if you take dy over dx, you just get negative 1. So clearly, both solutions are the same. Actually, I think I made a mistake here. Yeah, I made a mistake. Let's try that one again. I did not solve for y correctly. Move to the other side, get 1 over y is equal to 1 minus 1 over x. That's what you get. So 1 over y is equal to x minus 1 over x, or y is equal, and now you flip it to x over x minus 1. Okay, so now let's do this. So now we get dy over dx is equal to, maybe I should have just done it the other way. X minus 1 times 1 minus x times 1. Okay, yeah, over x minus 1 squared. So, which is equal to negative 1 over x minus 1 squared. Let's plug in what we have here for y. So we're going to have negative x over x minus 1 squared. So this will be squared, and this is going to be squared over x squared. And so this is going to go here, and these are going to cancel. So this is going to become negative 1 over x minus 1 squared. So both answers are correct. Okay, next problem is problem 4. We have cosine x plus the square root of y is equal to 5. So doing the same thing, we get sine of x plus half y to the negative a half dy over dx equals 0. or in other words, we get 1/2 square root of y dy over dx is equal to negative sine of x. So then we get rid of this, so that's 2 square root of y. So that's what dy over dx is. And there should be a negative here because the derivative of cosine is negative sine, so this negative would vanish when we flip it over. Okay, so now let's try it the other way. Let's see. So we're going to get square root of y is equal to 5 minus cosine of x. So we square this. That's what y is equal. So y prime is going to be 2 5 minus cosine x times sine x. Now let's plug in y over here. So this is going to give me sine x times 2. And then I'm just going to plug this in and the squares are going to cancel. So it's going to be 5 minus cosine x. So we get the same thing. Very cool. Okay. So now we're just going to find stuff using implicit differentiation. So the first question is x to the third plus y to the third is equal to 1. Again, I highly encourage everyone to do this with, first thing, all the notations are important, Newton's and Leibniz's, and second thing, understand why this works with the chain rule, but then you can just do this immediately. So this is just going to be 3x squared plus 3y squared y prime is equal to 1, or 3y squared y prime is equal to 1 minus 3x squared. And then you just divide by 3y squared. Sorry, this should be a 0, and so there's a 0 here, and so you just get a negative over there. Okay, next problem is problem 6. 2 square root of x plus square root of y is equal to 3. So we get 2 1/2 f x to the negative a half plus 1/2 y to the negative a half dy over dx is equal to 0. Again, the reason this comes up is because we're taking the derivative in terms of x. We're taking dx of this whole thing. And dx of the square root of y, you can't really talk about the change in x when everything is in terms of y, except for the fact that y can be written in terms of x. So by the chain rule, this is equal to dy of this thing, which is this, times dy over dx. That's by the chain rule. Okay, that's equal to 0. So we're going to have 2 is going to cancel, 1 over the square root of x plus 1 over 2 square root of y dy over dx is equal to 0. Move this to the other side, we get a negative 1 over the square root of x, multiply by that, and we get 2 square root of y. So we get dy over dx is equal to negative 2 square root of y over the square root of x. Next problem is problem 7. We have x squared plus this minus y squared is equal to 4. So what we get is 2x plus, and then we get x, and then dy over dx, the derivative of that, plus y times the derivative of this, which is 1, minus 2y dy over dx is equal to 0. Or in other words, we can take out the dy, so we're going to get dy over dx of x minus 2y is equal to, and let's move this to the other side, negative 2x minus y, and then divide by this, so x minus 2y. Okay, next problem. That was problem 7, so now problem 8. 2x to the third power plus x squared y minus x y to the third is equal to 2. Let's do this using a different notation. So this will be 6x squared plus 2y y prime plus y 2x, right? So again, this, and then we take the derivative of that, and then plus that, and then we take the derivative of that. But again, when we're taking the derivative of this, it's in terms of x. So again, by the chain rule, this gets, we spit this out to some degree. Minus 3 times the derivative of that, which is 3y squared y prime plus y to the third times the derivative of that. Okay, the negative is on the whole thing, so there's a negative over here. It's equal to 0. So now let's take out the y prime. So we're going to have y prime times x squared minus this part, so that's x to the third power. Is that just, what is that? That's 3x, that's what it's supposed to be. Okay, 3, and then that times y squared. Okay, so that's that. And then that's going to equal, so when that moves to the other side, it becomes plus. And then when this moves to the other side, it becomes minus. So minus y 2x. With this moves, it becomes minus 6x squared. Then we divide by this, so we have x squared minus 3x y squared. So right, we get y prime is equal to that. Next problem is going to be, let's just skip to problem 10. Yeah, I just did problem 8, so let's skip to problem 10. So we have y to the 5th power plus x squared, y to the 3rd power is equal to 1 plus x to the 4th power times y. So we're going to get 5y to the 4th power y prime is equal to x squared 3y to the 2nd power y prime plus, not equal, plus y to the 3rd power 2x, that's that, is equal to 1 vanishes, and then we get x to the 4th times the derivative of y, which is y prime, plus y times the derivative of x to the 4th, which is 4x to the 3rd. So now, so we're going to have that, and we're going to move that to the other side. So we get y prime is equal to, times 5 times 4y plus, so that's that, plus this, so that's x squared 3y squared minus, and then that is going to give me x to the 4th. Okay, that moves to the other side, so it's equal to negative y to the 3rd 2x, and then plus that, so y plus y 4x to the 3rd. Okay, and then all we do is we divide by this over here. So let's just write this up there. So negative y to the 3rd power 2x plus y 4x to the 3rd. That's that. That's that. Okay, perfect. That's y prime is equal to this. let's skip to problem 14. So we have y sine of x squared is equal to x sine of y squared. So this is going to give me y times the derivative of this, which is cosine x squared times 2x, plus, and then I'm going to have sine of x squared times the derivative of y, which is dy over dx. It's equal to here, so I'm going to have that is going to be x sine x, and then the derivative is going to be cosine of y squared times 2y times dy over dx, plus sine of y squared times the derivative of x, which is 1. Okay. So now, I'm going to have dy over dx as times, this is going to be that, so it's going to be sine of x squared, and that's that. Then this is going to move to the other side, so it's going to be negative cosine x cosine y squared 2y. That's going to equal to, so this stays positive, sine y squared, and this is going to move to the other side, so it's going to be negative, so minus y cosine x squared times 2x. So that's another equation. So now what we get is the following. Dy over dx is equal to, we have this thing, it's going to be sine y squared minus y cosine x squared times 2x over, and then this, right, because again we're going to divide by it, we're going to put that down there. So sine x squared minus x cosine y squared 2y. The next problem I'm going to do is problem 16. I'm going to skip the odd ones. Yeah, hopefully I'll be able to finish this in half an hour. Okay, so problem 16 is, we're going to have, let me write down what the equation is. So what we have is the square root of x plus y is equal to 1 plus x squared y squared. So we have a half x plus y times the derivative of this. So that's going to be, negative a half over here. 1 plus y prime is equal 1 and 0. So then I'm going to have x squared times the derivative of that, which is 2y, y prime, plus y squared times the derivative of that, which is 2x. Okay. So this can multiply so basically we're going to have 1/2 x plus y to the negative 1/2 times 1, and then plus multiplying this by this. It's going to be a half x plus y to the negative a half times y prime. And then I'm going to just move this over, so I'm going to get negative 2y, y prime is equal, and I'm actually going to move this over to the other side, so I'm going to get negative a half x plus y to the negative a half, and then plus that, so plus y squared 2x. And now what I can do is, again, I can take out a y prime, I can erase the y primes over here. Now I can divide by this, so I get y prime is equal to this thing, which is negative a half. Well, let's just do it this way. Half x plus 1 to the negative a half minus 2y. And I just erase all of this. And I'd say y prime is equal. Okay. Next problem is going to be problem 18. So we have tangent of x minus y is equal to y over 1 plus x squared. So this is going to be secant squared of x plus y, x minus y times the derivative of thing inside, which is 1 minus y prime, is going to be equal to 1 plus x squared times y prime minus y times 2x over 1 plus x squared. And then what we're going to do is we're going to have secant squared x minus y minus, right, so this is that times that, minus y prime secant squared of x minus y. Okay, we would have to move that over there. Okay, so this is going to be times y plus x squared squared, and we're going to multiply this also by that. So this is going to be 1 plus x squared squared. That's multiplying over there. And this is equal to 1 plus x squared y prime minus y 2x. So now we have the y primes alone and the things without y prime alone. So we will say that x squared, minus x squared, because we're moving it, y prime minus y prime secant squared of x minus y times 1 plus x squared is going to be equal to, and this part, which is 1 plus x squared times secant squared of x minus y, and we're moving it so it's a minus over there, plus 1 plus minus y 2x. So we're basically going to take out the y's over here, and then we're going to divide by the rest. Not sure I actually have to do this. Yeah, that's not, I mean, it would rhyme, and it's just algebra. Okay. Problem 20 is, we have sine of x plus cosine of y is equal to sine of x cosine of y. In other words, so we have cosine, so now taking the derivative of both sides, we have cosine of x plus, so minus sine of y dy over dx is equal to sine of x times negative sine of y dy over dx plus cosine of y cosine of x. So again, we'll do the same thing. We'll move this to that side, move that over here, take out the dx's, and then divide by this. We can kind of, I guess, anticipate how this is going to look. Right, we move this over there, we get a negative, and this is on the bottom. We have negative sine y minus this part over here, which is sine of x, and there's a minus because we moved it, sine of x minus sine of y, and then this is going to be negative cosine because it's going to go to the other side of the equality, and then we're going to have plus this, plus cosine y cosine x. So now, okay, that's finished with that. Now we're going to do problem 21. You have if f of x plus x squared plus x squared f of x to the third power is equal to 10, and f of 1 is equal to 2, and f prime of 1 is equal, so find f prime of 1. So let's see. So taking the derivative of both sides, we're going to get f prime of x plus x squared times 3 f prime of 3 f of x squared f prime of x plus, and then we're going to just have f of x to the third power 2x is equal to 0. So let's plug in what we know. So we have f prime of x, and let's take out this f prime of x, and so we're dividing by 1 plus this. Okay, so this is going to equal to negative over here, so it's f of x to the third power 2x negative, because we're moving it, divided by, oh wait, so we have an f of x here, we have an f of x here and an f of x here, so it's 1 from here plus x squared is that, 3 f of x squared. So we're going to have f prime of 1 is equal to, so I'm going to have negative 8 times 4 over 1 plus 4 times 3 times 4. Sorry, when you plug it over here, you get a 1, so this should be a 2, and this should be a 1. So you're going to get negative 16 over 13. Okay, fine. So now, our next problem asks if g of x plus, so g of x plus x sine of g of x is equal to x squared. We want to find f prime of 0. We're not given any other information, so let's see how this happens. So g prime of x plus x times cosine g of x, g prime of x, plus, I'm going to have sine g of x is equal to 2x. So plugging in 0, we get g prime 0 is equal to, and here we're going to have a 0 because this x is 0, so this whole thing is 0. Here we're going to have a 0, so we're going to end up with negative sine of g of 0. So we need to know what g of 0 is, which is simple to figure out if we just plug in 0 into all of this. We got g of 0 up here plus, and because of this x, this whole thing is 0, is equal, and plugging in 0 here, we get 0 here, so g of 0 is 0. So this becomes is equal to, and so this is 0, so this is negative 0 or 0. Very nice question. So now it's trying to, they write regard y as an independent variable and x as the dependent variable. So the independent variable, so generally for us, x is the independent variable. It doesn't depend on anything. We just move along here, and y depends on x. So given a certain x, you give back a certain y. So y is the dependent variable. But now we're going to flip that. We're going to imagine that x is the independent, y is the independent variable, and x is the dependent variable, and we want to use implicit differentiation to find d of x over d of y, right? Because generally we look for dy over dx. Basically, we're going to do the exact same thing. They're just trying to trick us a little to see if we really understand what's going on. And they're asking for x to the 4th, y squared, minus x to the 3rd, y plus 2x, y to the 3rd equals 0. So in order to find this, we're basically going to do the exact same thing, but now we're treating x's as y's. It's going to be x to the 4th times the derivative of this, which is just going to be 2y now, plus, now we're going to have 2y, and now the derivative of this, which is going to be 4x to the 3rd dx over dy, minus, and now we're going to do that over here again, minus 3x times the derivative of y, which is 1 for us now, plus y 3x squared dx over dy, plus 2x 3y squared, plus y to the 3rd 2 dx over dy equals 0. So we get that. So now we're again going to just solve for dy. So the dy's are this, and that. We're going to have dx over dy. It's going to be y squared 4x to the 3rd plus this plus y times 3x squared, and then plus this, which is plus y to the 3rd times 2. This is equal to negative x to the 4th 2y, that minus turns into positive x to the 3rd minus that minus 2x 3y squared. So now we just divide by this, so we get what we get is y squared 4x to the 3rd plus y 3x squared plus y third times 2. That's it. So now this is dy over dx. Okay, I'm going to skip problem 24. So now I'm going to do problem 25. Use implicit differentiation to find an equation of the tangent line to the curve at a given point. First we have an ellipsoid, so this is problem 25. We have x squared plus xy plus y squared is equal to 3, and we're looking at the point 1 comma 1. So we have 2x plus xy prime plus y plus 2y y prime is equal to 0. So now we're going to plug this in, so we're going to have 2 plus, and here is going to be 1, so y prime, plus, and this is 1, plus 2 times, so this is going to be 2y prime is equal to 0, or in other words, we're going to have y prime times 1 plus 2, which is this, it's equal to negative 3, which is that. So we divide over here by 3, so we get y prime is equal to negative 1. So that's the slope of our line, of our tangent line to this, for this ellipsoid. And then we just use the equation of the line, y minus 1 is equal to negative 1, x minus 1, and that's okay. Next problem, we do the same thing. I'm going to skip some of these. Let's do one more. So problem 30. It's called the devil's curve. Again, we want to find the tangent line, y squared minus 4 is equal to x squared times x squared minus 5. This is at the point 0 comma negative 2. So what we have now is we have y squared times the derivative of that, which is 2y y prime, plus this, which is y squared minus 4 times the derivative of this, which is 2y y prime, is equal to the derivative of this, which is x squared 2x plus x squared minus 5 2x, plugging in the point 0 negative 2, so this becomes 4 times 2 times negative 2 times y prime plus, so this is 4 minus 4, so this is 0, is equal, this is 0 because that x is 0, and this is 0 because of x is 0, so 0. So I get y prime is equal to negative 8. Sorry, y prime is equal to 0, right? Because you divide by this, you get y prime is equal to 0 over there, which is 0. So we have y minus 2. Minus 2 plus, which is plus 2 is equal to 0. So y is equal to negative 2. Okay. So now problem 32 says the curve with the equation y squared is equal to x to the third plus 3x squared. It's called a, I don't know, something cubed. Find the equation of the tangent line at the point 1 comma negative 2. So we're going to have y squared, I'm not going to graph it, but is equal to 3x squared plus 6x. So what we have is negative 4y prime is equal to 3 plus 6, which is 9. Put a negative 4 over there, so that's the slope at that point. Now they ask us, this is problem 33, find y prime prime, the double derivative by implicit differentiation. So we have 9x squared plus y squared is equal to 9. So first we have 18x plus 2y, y prime is equal to 0. Next we have that 18 plus 2y, y double prime plus y prime times 2y times 2y prime is equal to 0. In other words, we have that 2y, y double prime is equal to negative y prime 2y prime minus 18. We just divide by 2y, and that's what y double prime is. So next problem, same thing. We're going to have the square root of x plus the square root of y is equal to 1. We're going to have a half x to the negative a half plus a half y to the negative a half y prime is equal to 0. Or in other words, well, let's keep it this way. So then the next time we differentiate, we're going to get a half times a half x times negative 3 over 2 plus, and over here we need to use the product rule. It's going to be a half times negative a half y to the negative 3 over 2. That's the derivative of this, so y prime plus, then keeping this the same, so it's going to be a half y to the negative a half. And then we're going to have y double prime. This is equal to 0. So basically we move all this to the other side. So we're going to get y double prime is equal to negative a half times negative a half x to negative 3 over 2 plus, minus a half times negative a half times y to negative 3 over 2 y prime all over this, which is a half y to the negative a half. Okay, so I am going to ignore the next problems and problem 37 and problem 38. So now the next problem, the next interesting problem is going to be problem 39. Find the point on this curve, and the curve is found in exercise 29. So the curve is 2x squared plus y squared squared is equal to 25 x squared minus y squared. And we want to find the point where the tangent is horizontal. So basically we want to find the point where y prime is equal to 0. So let's take the derivative of this. We're going to get is 4x squared plus y squared times 2x plus y plus 2y y prime is equal to 25 2x minus y minus 2y y prime. So now what we can do is we can move this to that side, so we're going to have 4x squared plus y squared 2x. Oh no. Now we have to multiply this out. So this is going to be 4x squared plus y squared times 2x plus 4x squared plus y squared times 2y y prime is equal to 25 times 2x minus 25 times minus 2y y prime. So now I get that 4x squared plus y squared times 2x minus this minus 25 times 2x is equal to minus this, so minus 4x squared plus y squared 2y y prime, and then minus that, which is minus 25 negative 2y y prime. So now let's erase all this. Okay. Let's see, if we want, we're going to take it a y. Okay, so if we want y prime to be 0, we set this to be 0 and this to be 0, so this whole thing is 0. So what we want is this to be 0. So what we want is 4x squared plus y squared times 2x is equal to 25 times 2x. These cancel. This goes over here. So we want x squared plus y squared to be equal to 25 over 4. Or what we want is y is equal to 25 25 minus over 4 minus x squared square root plus or minus. And this is just a whole list of points. It's an equation that just satisfies well, any point on here, if everything that I did was correct, would satisfy that their tangent is horizontal to the original curve. Yeah. But we also want specific points that are on the curve, right? We don't want to randomly choose points that are not even on the curve. So we can say, what we can say is we don't even want all of these. We want points that both satisfy the equation of the curve that we were given, which can be found on top, and are also satisfy this claim. So we can plug this in here, so we're going to get 2 times 25 over 4, right? Plugging it into the curve to find points on the curve that satisfy this is equal to 25, and then x squared, right, we have that x squared is equal to, so x squared over here is going to equal to 25 over 4 minus y, and then minus over here. So what we're going to get is 25 over 4 minus 2y squared, right? If we just plug in what we have for x squared. And so then, let's see, so this comes over here at 25, and then we take minus this. So we're going to get 25 over 4, right? We have minus that, plus 2 over 25, times 25, so this is that, and then 4, so this is going to be 8, no, sorry, it's going to be 2, right? Oh, wait, sorry, this is squared. Here is squared, so this is squared, so we can't do any of that. Okay, let's try this again. I have 25 over 4 minus this. And I'm not going to think about what the square does. 25 over 4 squared. And then I'm going to divide all this by that negative 2. And I'm going to take the square root plus or minus, and that's equal to y. So when y, so for all y's that are equal to this, and now we can also find x, we're going to have that the horizontal line is tangent. And there'll actually be, I assume, 4 y's that satisfy this because the curve looks something like this. So it will be this point and that point, and we're going to have these points as the places. So 4 points to satisfy that. Okay, next problem. I know I'm over an hour, but I just want to finish implicit differentiation. Problem 40, show by implicit differentiation that the tangent to the ellipse x squared over a squared plus y squared over b squared equals to 1 at point x naught, y naught is x naught x over a squared plus y naught y over b squared is equal to 1. So this we want to show. Okay, so again we want to solve for y prime, I guess. So what we're going to get is 2x over a squared, right? 2x over a squared plus 2y y prime or b squared is equal to 0. Or in other words, 2y y prime over b squared is equal to negative 2x over a squared, or y prime is equal to 2x b squared over 2y a squared negative. So if we plug in a given point x0, y0, we get that y prime is going to be 2a0, 2x0 b squared over minus 2y0 a squared. This is the slope. So now let's find the tangent line, or all the tangent lines to the slope. So that's going to be y minus y0 is equal to m, and m is going to be 2x negative 2x0 b squared over 2y0 a squared, and let's just multiply this by x, plus, because the minus becomes plus. Right, we have the x0 here, so this is going to be 2x0 squared b squared over 2y0 a squared. So we can actually take the entire bottom part, take it out, move it to the other side. So we're going to get y minus x0. Let's write it out actually. Y times 2y0 a squared minus y naught y squared. Y naught squared. That's that. So 2a squared is going to equal to 2x0 b squared times x plus 2x0 squared b squared. So now let's get rid of this. Let's group the y0 squared and the x0 squared together. So we're going to have y times 2y0 a squared, and then minus this, minus 2x0 b squared x is equal to y0 squared 2a squared plus 2x0 squared b squared. Okay. Dividing everything by a squared b squared just to get rid of them, or the ones that we don't need. So when we divide everything by a squared b squared, we're going to get y 2y0, a squareds are going to cancel, and then we're going to get b squared minus, and over here we're going to add 2x0, the b squares are going to cancel, so we're going to get a squared is equal, over here we're going to get y0 squared, the a squares are going to cancel, we're going to get a 2 over there, over b squared plus over here the b squared is going to cancel, so we get 2x0 squared over a squared. So all the 2's, we can just take the 2's out and then divide by it, so we can get rid of all of them. And this is equal to 1, because for any x and y, we're going to have x squared plus y squared. For that is equal to 1, so this is going to be 1. So what we have is y0 minus x0x b squared a squared is equal to 1. And what we were trying to prove, something a little different. So I assume I just made a small mistake in a sign at some point. We're trying to prove that the tangent lines are of the form x0 x over a squared plus y0 y over b squared is equal to 1. So I assume that this just needs to be plus, and we'll be done with that problem. Okay, I'm not going to do problem 41 or 42. I am going to do problem 43. So it says, show using implicit differentiation that any tangent line at a point P to a circle with center O is perpendicular to the radius OP. So this makes perfect sense. You have this radius, and we want to show that any tangent line at a given point, so this is O and this is P, any tangent line at a given point is perpendicular to the line PO, which makes complete sense. So how do we show this? So let's put O at 0, 0, 0, and so the line, the slope of this line, so we'll call this x0 comma y0, right? So take P is equal to x0 comma y0, so the slope is going to be y0 minus 0 over x0 minus 0. In other words, y0 over x0. So that's going to be the slope of the radius. And the circle itself, we have x squared plus y squared is equal to r squared. So using implicit differentiation, right, so the slope of PO, we said, is equal to y0 over x0, right? Yeah. So over here, we're going to have 2x plus 2y, y prime is equal to 0. In other words, 2y, y prime is equal to negative 2x. So we divide by 2y, get rid of this. So the slope at any point is going to be plugging in that point, negative x0, negative y0. And so this is the negative reciprocal of that, right? x0 comma y0 is the negative reciprocal of negative x0 over negative y0, and we know that if a slope is the negative reciprocal of the other, the two lines are perpendicular. So this is why we get, for any point, this line and the line tangent to that point are perpendicular, right? For this point, I have this line and that line are perpendicular, if I drew it correctly, which I did not. Okay, so I'm not going to. So this is it for implicit differentiation. I would have liked to do problems 45 to 48, but they don't actually really matter. The important thing is to know how to just take specific problems and just do the straight out implicit differentiation. A question like that will probably appear on a Calc 1 test. Everything else probably won't. It just helps with the intuition and the understanding. But just know how to take a equation with x's and y's in it, and how to do implicit differentiation, and probably also how to do a second implicit differentiation, because I would not be surprised if that also appears on a test. The next video is going to be about rates of change, and I think, let me see, there's going to be one section of rates of change. So rates of change and then related rates. That's going to be the next couple of videos, maybe 2 or 3. Okay, hope this was helpful.